Hi, my name is Oktay. Welcome to today's video about the Milky Way Galaxy. This is an edge-on view how an extragalactic observer would see the Milky Way. The Milky Way Galaxy has a diameter of about 100,000 light years. Its disk height is about 1,000 light years. In the middle there is a spherical structure, it's called a bulge, and its diameter is about 10,000 light years. This is how the Milky Way Galaxy probably looks like. We are in the middle of the disk. That's why it's a bit difficult to observe all regions of the Milky Way Galaxy. But we know it's a spiral galaxy. The spiral bar has a length of 25,000 light years. Milky Way contains 100 to 400 billion stars. And its total mass is about 0.89 to 1.5 trillion solar masses. You can see the main spiral arms, this one, and the spiral arms are density waves. The Sun is located 26,000 light years from the center in the Orion Arm. That's a minor arm, about here. And what's important is 90% of the matter is dark matter. That's very important to keep the structure of the Milky Way Galaxy. This is the artist's impression of the dark matter around the Milky Way Galaxy. This is an animation of the 2000 brightest stars within 500 parsec. That's about 1630 light years. The Sun in this picture is a blue dot. And you can see in the middle a higher concentration of bigger stars, and that's a part of the structure of the Orion Arm. This is a picture of the nearby stars around the Sun. Sun is here in the middle, Sol. And you can see most of the stars around the Sun, as well as the galaxy, are red dwarfs, M stars. That's 75%. They have a typical mass of about 10 to 60% of the Sun's mass. And one example is Proxima Centauri, the closest star at a distance of 4.2 light years. It is part of a triple star system that contains Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. And the mass of the Sun is about 2 times 10 to the 30 kilograms. That's another neighbor of the Sun. That's Cygnus-X A. It's a very big star. This structure is called local Fluff. It's a local interstellar cloud with a size of 30 light years. The Sun and the solar system is in this cloud. And it has a less dense than the average interstellar medium at just 0.3 atoms per cubic centimeter. The Sun will exit the local Fluff in about 1,900 years. This is a bigger structure we are in. That's called a local bubble. It's a bigger cavity in the interstellar medium with a size of 1,000 light years and a density of just 0.05 atoms per cubic centimeter. This is how the solar system entered the local bubble about 5 to 10 million years ago. And of course, eventually, the solar system will exit the local bubble. The star Geminga was for many years the prime candidate for the formation of the local bubble. It is a neutron star former star that has exploded. And it's a pulsar at 800 light years distance. Its supernova, it could be that its supernova has created this local bubble. But nowadays there are other candidates, other stars that also are possible for the possible explanations for the local bubble system. This is a picture of the Orion Arm. It starts about here and goes all the way here. It has a length of 20,000 light years. It's a minor spiral arm. Its width is about 3,000 light years, and it is not clear where it starts. It starts somewhere near this big arm, Saggitarius. But is it just near this big arm, or is it like a side alley of the Sagittarius arm? That's difficult to determine. Here's another picture of the Orion Arm. You can see the sun is here. And one nearby structure is the Orion Nebula at 1,344 light years. It's a star formation region with a size of 24 light years and a mass of 2,000 solar masses. So this is the Orion Arm, here to here. Another region is Cygnus-X. That's a massive star formation region at 4,600 light years distance with a size of 650 light years, and it contains 2,600 O-type stars. This is a Spitzer image from the star formation region Cygnus-X. This is a nice picture that shows you the ecliptic plane. That's the plane of the planets around the Sun. It is not in the galactic plane. That's the disk of the Milky Way. So the solar system rotates around the center of the galaxy. The orbital period of the Sun and the solar system around the galactic center is 225 to 250 million years, and its orbital speed is 230 kilometers per second. That's a very impressive number. It could be that the Milky Way has a potential. It could potentially have a habitable zone, and that's this green zone in this picture. In the inner region, the high activity is too high. That's not good for life. And in the outer region, the metallicity is too low. Metallicity means the percentage of all chemical elements other than hydrogen and helium. And what's very interesting is that the ratio of carbon to oxygen is not constant within the Milky Way. There's more carbon in the inner Milky Way regions. So there could be carbon-rich planets in the inner Milky Way. And the age of the Milky Way is 12.6 billion years. That's not much less than the age of the universe, which is 13.8 billion years. This is the disk of the Milky Way Galaxy. There's a thin disk with a height of 800 to 1,000 light years. That's this green disk. And there's a thicker disk with a height of 2,000 light years. And the thick disk contains lower metallicity stars. This is a picture from the side of the Milky Way. The disk of the Milky Way is not flat, it is warped. And there are several factors that cause this warped disk: interactions with satellite galaxies, gravitational forces, and orbital motion. And in this picture you can see the Magellanic Stream. It comes from the interaction of the small Magellanic Cloud with the large Magellanic Cloud. And you can see the halo of the Milky Way and globular clusters. This is a picture of Hubble, found white dwarfs in the central hub of the Milky Way. These are 4 examples. These blue dots are white dwarfs. White dwarfs are final stage of a sun-like star. After it explodes in a nova, loses about half its material, and it becomes a white dwarf with a size of about Earth size. This is a Chandra image of the galactic center. It contains the supermassive black hole Saggitarius A star. Has a mass of about 4 million solar masses. Now this is a very interesting picture. One star in this picture is very interesting. This star. You can see it. Its orbital speed is not constant. Here at the bottom, it's much faster. This is a 20-year time-lapse of the stars that are moving around the Sagittarius A star. And one star is very interesting, that's the star S2. It has an orbital period of 16 years, and it's a massive star with 10 to 15 solar masses. Its closest approach was in 2018, when it came as close as 120 astronomical units. One astronomical unit is 150 million kilometers. And at this closest approach, it had a speed of 7,650 kilometers per second. That's 3% of the speed of the light. This is a picture of the motion of the star S2. In the year 1992, it was here. Then within 9 years, it made about half an orbit. It was in 2001. And from here to here, that's about 1/4 of an orbit. And that quarter it made in just 1 year. So here it had a maximum speed. And the observation of the stars near the supermassive black hole helped calculate its mass. This is a newfound object X7. It could be a gas cloud. It is located near the supermassive black hole Sagittarius A star, and it will be probably ripped apart in the year 2036. Then it will be something like this. Here, this animation of matter approaching a supermassive black hole. Some of the matter falls into the black hole, some is ejected by the jets, and some is ejected into space. This is an image of the Event Horizon Telescope of the supermassive black hole Sagittarius A star at a distance of 26,000 light years. And this, you can see the glowing gas around the supermassive black hole that is in the accretion disk, and the friction causes it to glow. This is a nice visualization of a supermassive black hole with its accretion disk, and if matter falls into the black hole, then you get the jets at the poles, and the matter in the jets is accelerated to a very high speed. This is a nice view of the Milky Way from Pakistan's Karakoram range. This is a nice panorama picture of the Milky Way at Bonteku Lake in the state of New York. And this was a big sensation last week from the near-Earth asteroid 162173, Ryugu. Ryugu was visited by the spacecraft Hayabusa 2, and the spacecraft brought back samples from this asteroid. And now it turns out that the samples contain the molecule niacin, which is the vitamin B3 molecule. And what's more interesting is the molecule uracil. That's one of the 4 nucleobases of RNA, and RNA is the molecule that is related to DNA. It's very interesting. And here you can see the structure of this molecule. Black is carbon atoms, white is hydrogen, oxygen is red, and nitrogen is blue. It's very interesting and very fascinating. That was today's video about the Milky Way Galaxy and its structure. Thank you for watching. Have a nice day. Bye-bye.